Hello everyone, welcome to the new lecture which is about image matching for DSM generation using absolute difference, squared, sum of absolute difference and sum of squared difference and then normalized cross correlation. The outline of this lecture, first I will start with introduction, then I will talk about the method, the mentioned method about the DSM generation, and at the end I will uh, finalize with conclusion. Let's talk about the importance of the stereo matching in DSM generation. Actually, stereo matching or image matching is used to find the object coordinate. Uh, it's used to find the object coordinate from the image coordinate. What we will do, for example, if we have a stereo images, first we will identify a point on the left image and then we will search for the corresponding point on the right image. This is called image matching and will be done automatically by using some algorithms. If we define the corresponding point and we have the image point, for example, on the left image, then we will be able to measure the distances or x and y coordinate for each point on the image or image coordinate. We will be able, by using triangulation, in order to find the object coordinate. This is simply, which means the image matching and using correlative equation. The stereo matching, first we will rectify the images. The image rectification or normalization is the purpose of the image rectification or normalization in order to minimize the cost search and respect to the time. Instead of searching the whole image, what we will do, we will rectify the image, which means the y value in both images are equal and there remain only the x parallax. Then we will identify a point on the left image, and after that we will search for the corresponding on the right image by using some image matching technique. As you can see here, when we identify the image, it will search for the right image. What we will do, first we will identify a point here, then we will locate a window around the point, then we will search for the corresponding point on the right image, and the purpose of the fitting window around the point in order to give more robust result. Let's talk about the first method, which is AD or absolute difference stereo matching method. In the absolute difference, it measures the dissimilarity between two pixels only. It doesn't take surrounding points. It compares only signals aligned along the equivalent lines with each other. Excuse me. The corresponding point is based on the lowest energy. The used formula is AD, which means intensity value on the left image minus the intensity value on the right image and the absolute difference, and we will compare the AD for each, or we calculate the AD or absolute difference between this pixel and each pixel along this line, and the minimum one will represent the corresponding point. We have an example, as you can see here. We have this pixel, which is row 4, and in column 5 it's 84, and we will trying to find along this line for the corresponding point. What we will do, we will find the absolute difference between this point 84 and each of these points. The minimum one, it will tell us, which is means represent the corresponding point. As you can see here, we have 84 minus 113, 29, minus 180, it's 96, 34, 10, which and 79. This is the lowest value, which means the corresponding point is 84, and 84 minus 94. This is the corresponding point with respect to the absolute difference method. Then what we will do, we will apply the algorithm on each epipolar line, as we applied on this previous example on one line. Now we are going to apply on each line individually until all the image is covered. The code has been, actually I have written a code by using C++ software, and it's available on GitHub. On this link, you can download the code and apply it by using C++. Actually, the available code is just for finding the corresponding point, and in order to find the image coordinate on the left image and right image for the triangulation, you have to use another code. This is the obtained DSM for based on absolute difference. As you can see, this is the building here, and this similar building is appeared here, and this is the building here, similar. But as you can see, there's a lot of noise. If we produce the DSM or triangular irregular or the mesh triangular irregular network, it will be represented on this value. Still, there is a lot of noise on this DSM that produces with absolute difference. Now let's apply sum of absolute difference, SID, serial matching method. Excuse me. Sum of absolute difference is one of the simplest methods of similarity measure. It's calculated by subtracting pixel in a square area between the reference image I1 and the target image. Instead of using just subtracting one pixel, what we will do, we will fit a window around the pixel, and we will subtract each pixel value from the other inside the window. This process is followed by the aggregation of the absolute difference within the squared window. If the left and right images coincide exactly, the result will be 0, as the procedure is summarized in the below equation. Similarly, like absolute difference, we will take the minimum minimum difference. As you can see here, this is the absolute difference for the first pixel, and absolute difference on the left image and absolute difference on the right image, and we will sum of all the absolute differences. This is a numerical example, the same example, but using sum of absolute difference. As you can see, first we will take this pixel, and we will take first pixel on the row on the same row on the right image, and we will fit a window. What we will do, we will subtract 41 by minus 100, 41 minus 100, and 150 minus 134, and the absolute difference, and we will sum, and we will get the aggregation. This will give us the value 603 for the first pixel. Now we will move the window to the other pixel, this one, and we will fit similarly the window. Then we will get 544, which is less. Then we will move to the other window with 431, and then the other window we will get other pixel, we will get 94, and finally the last pixel, it will give us 101. This means this the minimum value is 431, which is represented by this pixel, which means the corresponding point for this pixel is represented by 118 along the right image. Similarly, what we will do, we will take a sample, which means on the area, actually it was 300,000 column by 200 rows. It was total 6 megapixel, but although there's DSM generated, but still there's noise, and there's some roads appearing, but still it's noisy and it's not very clear. Let's move to the other one. The third one is sum of square difference. The absolute difference will be squared. Is one of the measure of match that based on a pixel by pixel density difference between two images. It calculates the summation of the square of the product of the pixel subtraction between two images. As you can see here, we will subtract and we will sum of the square, and then we will aggregate them. By taking an example, as you can see here, we will identify first pixel on the left image, and then we will search along this green line on the right image, and we will subtract 41 minus 100 squared, we will square it, and then 158 minus 134 we will square it, and so on, so it covers the whole window. We will get 56,907. Then we will get 44,737. We will get 27,435, 0.85. For the other pixel, we will get 85,291, and for the last pixel, we will get 137,637, which means this one, it was 27,000, this pixel. And the summary tells us that this one will give us minimum energy, which means the corresponding point is located on the pixel 4. And by applying the on the study area, as you can see here, the is slightly better than the sum of absolute difference, and the building is appearing clearly and less the noise than the previous two methods, which can be used to depend on it. Now, finally, we will talk about normalized cross correlation NCC method. It's chosen as a similarity measure due to its robustness. Its computation is more complex if we compare to the previous, as it involves numerous multiplication, division, and square root operations. Normalized cross correlation determines the matching point between template and image by searching the location of maximum value in the image matrices. The NCC computation can be expressed as shown here. The more important benefit of this one, you can limit, or you can identify a threshold value, because the correlation between -1 and 1. And for example, we can neglect the values that less than 0.85 or 0.8 or 0.95 to keep only the more robust or more robust matching point, or better matching point, and we can remove the suspicious point by increasing the level of the threshold. As you can see here, we have this example, similar the image, and what we will do first, we will find the average of this window, 41, 158, 150. Then we will find the average of this window, the whole pixel 3 by 3, and then by subtracting each pixels from the average, we will get this value, and then we will squaring them, we will get this summation. Similarly on the second image, and we multiplying this one by this one, we will get this value. By using this equation means this is the summation of the A minus Aj minus our average times B Ij minus B average, which is represented here. And this is the value, we will put it here. And for this value, we will use this one. And for this value, we will use this one. By taking the square root, we will get the correlation. The correlation is minus 0.25, which is very low. And this one 0.21, it's slightly better. And this 0.87, which is better than the previous two. And this minus 0.21, this is deteriorated. And this minus 0.73, which is more deteriorated, which means the corresponding point is located here, this pixel 4 by 4. And this is the summary. It tells us the correlation value 0.785965. It will give us the corresponding point, which is located in this one. The whole process is just for finding the corresponding point. By applying on the study area, and the code is available here, you will be able to get this DSM. As you can see here, by taking the threshold 0.85 and taking 9 by 9 window, we will get this DSM. By the way, the absolute difference, the sum of absolute difference and sum of square difference, we used also 9 by 9 window, but the result was not good as is shown here. If we increased the threshold value to 95, as you can see here, more better result we will be able to get, as you can see here. And this is the building here, and less noise than the using 0.85. But meanwhile, less matching point will be shown to us. If we increase to 0.99, which means only to extract the base point, it will give us more accurate, but the topology of the building will be lost and you will not be able to identify the building clearly. Just some point will be extracted. Therefore, you have to be careful when using the threshold value for in normalized cross correlation. Also, there is another method like least square method that will give you better result than this method, but these methods are specified to be very simple and easy to operate, and it's useful for the identify the initial matching point, which is this initial match point. It will be useful for least square method. The best method is now least square method and semi-global matching methods. And there's also deep learning method, and these are considered to be better than normalized cross correlation. There's a lot of methods you can find in the literature. In the conclusion, the AD is depend only one pixel, thus it doesn't be very accurate. The AD, ASD, or SSD does not accept threshold value for eliminate the bad match. The NCC is considered as the best method if compared to the AD, ASD, or SAD or SSD. The NCC method, the threshold value can be used to control the matching accuracy. Increasing the threshold value will lead to extract less point and thus will lose the object shape or topology. Decreasing the threshold value will lead to extract more point but with high mismatch. Thank you very much for listening. I hope you enjoyed and it was useful for you. Thanks a lot.